discussing the example that we did in class about the brand name batteries versus the generics, which last longer. Okay, this setup is a student decided to conduct an experiment with two different types of batteries, one a generic and one a brand name, AA batteries, and he put them in a CD player, put a CD on, had it repeat until the batteries basically died, and he recorded the time in minutes. And you can see in L1 that we have our times set up for our brand name batteries, and then L2 we have the generic brand. Now, anytime that we have a set of data, we want to first basically look at the data and see what it looks like. We can look at several types of plots to assess normality, to look at the range, to look at the center, the shape, different things like that. So let's just attack this problem from the very beginning. So it comes in kind of three parts: think, show, and tell. The first thing we do is basically we're going to plan what our steps are going to be like. So the first thing we do is state what we actually do know. Okay, some of these things allow us to identify parameters, and in turn, once we get to doing a significance test, once we know these indications, it helps us figure out what HO is, what HA is going to be, different things like that. So the first thing we can do is identify our parameter. In this case, we're really interested in how much longer one battery lasted versus another battery. So I'm really interested in the difference in how long each one lasted. So the difference between the means, not the actual means themselves. So I'm not technically interested in writing it all down in terms of, well, this one lasted 194 minutes and this one lasted 190.7 minutes. I'd rather know that, oh, this one lasted 4 minutes longer, or this one was 15 minutes shorter. That would make a much better indication, easier to understand. The next problem is identifying the population. In this case, we're using AA batteries. We've chosen two different brands. One is a brand name, one is a generic brand, and we're going to compare the times of them. Now, the next thing I want to do is make a picture of my data. There's two types of graphs that I would do here that would actually be very appropriate. The first one we're going to do is we're going to go to our stat plots. So we'll go to second y equals, and we're going to bring up my first stat plot. Now there's two things we can look at for getting a good picture of our data set. Now a histogram would be one of the first things we would look at. However, if you have a really small sample size, then you're not going to get to see a lot of the details of the data if it's small as we have now. With only, let's see, we have 6 data points, and so that's really not a lot. So what we're going to do is we're going to look at basically a modified box plot. So we're going to go down and choose my modified box plot. Make sure that my X list is my the ones that I've used. In L1 I've got my brand name, so we'll look at that first. So I'll go in here, I'll zoom 9. Okay, and I've got lots of other things graphing. So now what happens here is if you've got something in Y1, Y2, or anything like that, and you get all kind of weird stuff, sometimes you're actually getting to get errors. And if you get an error, the first thing you can do is go to Y equals and see if you've got things in here so you can clear those things out. And look up at the top when you're in your Y equals. If a plot has been turned on, it'll have a box around it. Okay, now we can go back to our graph. Now we can look at this. That's our basic box plot. You can see the minimums, you can see the maximum, you can see the median, Q1 and Q3. Alright, let's go back and look at our next one. So I'll go back to stat. I'll go to Y equals. This time I'm going to go down and I'm going to turn on the second plot. Now we want to plot them in the same time. They're on the same axis. They're the same type of data, so I can plot them at the same time. Plus that allows me to really get a feeling of what has a higher median, what's the range of both of them. I'm going to choose Y or L2 for my X list. This is my generic data, and I'll hit zoom 9 again to graph it. And we can see here that you get two major different box plots. One is a large box plot, got a fairly long range. The other one, if I don't consider the outliers, I have basically most of my data fits within this box. A fairly small range. Now if I consider the outliers, even then, if I consider this the min and the max, that's still going to have a smaller range than this one up top. So when we look at data, we want to look at the shape, the center, and the spread. We've talked about spread a little bit. Let's look at the center for a second. You can see here that on average, for the most part, my generic data, and you can tell which one switched by pressing trace. This is of course plot 1 with L1. I hit down and it'll go to the other one and it shows me that's L2. So my generic data does better for the most part. You have a couple of outliers and there's a little bit of overlap you can see right in here, which means that some of the brand name batteries lasted longer than some of the generics. But for the most part, most of my data is larger or is bigger than this. So you can, if I were to make an assumption, try to realize what's happening here, then I would assume that my generics are going to last longer. But let's find some actual scientific or statistical evidence to support that. Okay. So when we're doing this, shape, center, and spread, of course, we haven't really talked about shape yet. If I want to look at shape, I can see that it looks fairly symmetric from a box plot, but really box plots are not the best. So what we're going to do is we're going to press second Y equals, and I'm going to go in and I'm going to turn on a normal probability plot, which is the very last icon. So I'll turn this one, change it to this. I want to make sure that my data list is the same, and my data axis is going to still be X. I'm not going to change that. Now, I remember that I have both plot 1 and plot 2 turned on. I don't want them on at the same time. So I'm going to go in plot 2 and turn it off. All right, now we hit zoom 9, and we get a picture here that looks somewhat like a straight line. Okay, and for a small amount of data, it's not that big a deal. It's fairly symmetric, or fairly normal, which if we look at the next section is our modeling section, which is we're checking our assumptions and conditions. Our nearly normal condition, if you look at this, it's fairly close to straight line, and so we would assume that the normality part of it's been satisfied. All right, if you had a really curvy line, or if it was not even close to straight, you would throw that part out. Okay, so we'll go back in and we're going to look at the other side. So we need to go in and turn plot 1 off, or no, I mean not off, but we'll change our data list to L2 and then zoom 9 again. And this one here is definitely, at least not as good as the other one, but here again they're approximating a straight line here. And you have to remember that we still have a small set of data, so you're not going to get lots of data points. They're going to fall in and make a nice little straight line for you.